Hello everybody and welcome to today's session on the Apex roadmap where we're going to cover what's new and what's coming with Apex. Before we begin, first we'll do the forward-looking statement. So Salesforce is a publicly traded company, so it's important that you make your purchasing decisions based on products and services that are currently available. With that, I'd like to say thank you for your time today. I'm looking forward to running you through the roadmap, both you here in person and those who are online. I am Daniel Bellinger, the product manager for Apex.
Welcome everyone, I'm Bindu Nair, an engineer on the Apex team.
Right, so today we're going to run you through 4 key areas before giving you an overview of the roadmap in general. First, we're going to talk about what we're doing for data processing. So this is new features we have like zip processing in Apex, formulas in Apex, and the beta of cursors. Then we're going to talk about observability and things you can do within your Apex code to be more aware of what unhandled exceptions may be occurring. Then we'll talk about agent actions and how you can expand or use your existing Apex code through agents, both through invocable actions, and then we'll talk about how we can do that with REST. And then finally, we'll talk about what we're doing to enhance managed packaging as we transition from 1GP to 2GP, and the considerations you'll have to make there for your Apex metadata. So, first, what are we doing for data processing in Apex? We have a feature in Apex called cursors, which is currently in beta, and it's probably easiest to run you through as an example of why you would use that in your code. So say you had a scenario where you needed to do some processing based on all the contact records that were updated in the last 400 days. That could be quite a large payload of records, and you could have to do quite a variable amount of processing on that. Now you could use batch jobs, but if you did that, you'd have to be definitive up front in defining the scope of how many records each batch is going to process. And we'll walk through an example here of why queuables would give you more flexibility and a different path to approaching that. So again, we want to process all the contact records from the last 400 days. So we can use a dynamic SOQL query to express that and use that to establish the cursor. Once we've established the cursor, that's fully serializable, and this is the nice part. We can use it with a queuable job, and we can store the results of that cursor. But when I say store the results of the cursor, I don't mean actually store every single S object that matched that query. You're just storing the cursor. So that's a lot less heap usage for your current transaction to have to consider. Okay, so we have our cursor established, we know what results we're going to get back. How do we actually use it? Well again, serializable, so we pass it and we execute our queuable job. Within the queuable job, you can reference that cursor and fetch records. Now this is stateless, so here we're saying start the cursor from position 0 and fetch me the next 200 records. You could of course choose to retrieve more or less records from the cursor, depending on how you're going to process them. So then you process them. You might archive them, make call-outs to external systems based on them, do some processing, store the results. You've done that. Now you can look at what is my current heap and CPU usage like? Should I process more records in this cursor? In this queuable? Or should I instead examine how many total records are available in the cursor, which I can do with the getNumRecords method. And then I can say, oh, there's more records to process, I'm going to pass them along to the next queuable job, and it's going to process the next chunk of records.
Daniel, what happens if you run into some kind of a scaling issue and run into a CPU or limit exception?
Of course, yeah, that is the risk, right? So I'm trying to process quite a lot in my queuable job. There is a risk I'm going to run into a heap and CPU limit. But that's one of the nice features about cursors. They are stateless, and so you can combine them with something like a transaction finalizer. That will be able to capture and handle that heap or CPU limit, and you'll be able to observe your cursor and say, actually, you know what, I'm going to start this queuable again, but rather than processing all 200 records, maybe I'll only process 50 in the next chunk. So I can adapt to the data load, which is something you can't do with batch jobs. Makes it really hard to adapt to the unknown sizes. And also, cursors aren't just for chains of queuable jobs. You can use them with page controllers for your UI components. So if you need to do pagination through a large volume of records, you're no longer bound by the limits of the SOQL offset command, which only meant you could go to 2000, and you don't have to try and do weird primary key chunking in the where clause to move back and forward through that results set. And because it's stateless, you can jump straight to page 10 of the results if you want. Right, with that, Bindu, can you run us through zip and Apex, please?
Yes, thank you, Daniel. So we now have zip native in Apex. It's a pretty common use case in Apex to be able to extract zip files and write zip files. And what you're seeing here is a typical use case of how that's set up in Apex. you have an HTTP request that sets up a payload and makes a call out to a translation service. And the response that you're getting back from the translation service is essentially a zip archive, and it's captured as the blob data type here. Up until now, developers on the platform use a third-party tool called ZipX to be able to read this binary, and it's been doing a pretty good job of being able to do that. But we've had challenges with respect to some additional CPU cycles that are consumed given the fact that this is a third-party tool. So we have solved that problem now. We have 2 new classes as part of the compression namespace in Apex. Here's the first one, the zip reader class. It does what the name suggests. So the blob that we just got as a response from the HTTP call, you send that as a parameter to the zip reader class, and then you have methods off of that class to be able to read the archive and be able to extract entries. And the second class is the zip writer class. Again, the name suggests what it does. You're able to create archive files from it. So we'd love for you to check that out.
One important consideration of this is still within your Apex transaction. It's still bound by the heap and CPU limits of that transaction. So you're not going to be processing absolutely massive files, but for smaller zip files, this is an ideal solution.
Right, that's an important point. Now that we brought the functionality back into Apex, all the same governor limits will apply. Let's move on to formula evaluation in Apex next. And to be able to understand how this works, let's consider a business scenario. And I have Daniel here as a product manager. Daniel, help me here. Give me a business scenario to work with.
Okay, so we've been working with the account teams and the sales teams, and they're saying, we have some great accounts on our org, and we want to recognize them and make sure they're very happy customers. So we're going to send them a gift box under certain scenarios. So we might have customers who are considered, they have a hot rating on the account, we really want to recognize them. We might want to consider other sales factors, like what's their pipeline? Are they having seasonal promotions? Bindu, can you give me a solution for that, please?
Sure, let's try. Let's give this a try. So the problem at hand is that we need to be able to select accounts that meet a varied set of criteria. One such criteria, like Daniel just said, is that we choose accounts that have a rating of hot. Additionally, based on recommendation from the sales team, we have to be able to account for the sales pipeline value of these customers. And this box that you see here, sales pipeline, represents a separate service on the platform. So we need to also be able to encapsulate and account for that. There's also seasonal rules that apply to this decision making of what gifts are appropriate for what seasons, and they are region specific. Daniel, question back to you. When you look at a varied set of requirements like this, it's quite large and complex. What's like the top of mind challenges that you face?
Well, the one thing that strikes to me about any set of changing and evolving requirements is they're going to continue to change and evolve over time. We're going to need to be able to adapt. Like somebody might say, well, there's special rules for government customers. We have to do that. So the one thing I can tell you for certain is these are going to continue to evolve.
Right, that's not surprising, is it? We all know this and have experienced that requirements change over time. So the solution that we build here needs to be flexible and needs to be able to change dynamically. So as an Apex developer, I'm thinking formula fields is a good fit here because our admins understand them really well. But this is such a large and varied, diverse set of requirements that it's hard to express them as formulas based on just a few entity fields. This is almost like we are building some kind of a rules engine here. So let's look at how we would approach a solution for that in Apex. So instead of a static formula field, let's take that formula expression and make it part of a custom metadata type as step 1. So here's that formula. For simplicity's sake, we are taking 2 of those criteria that we talked about, the rating and the sales pipeline. And so we configure that as part of the custom metadata type value. As a second step, we define a global class in our org with 2 global properties. One is of type account, and the other is a method, a global method, sales pipeline. This is a method that knows how to call out to that external service and calculate the sales pipeline value for a customer at runtime. And this step is important because formula in Apex can be evaluated based on Apex objects. And given the fact that it's an Apex object, which is just a class in your org, you have the ability to harness all the other capabilities of the Apex subsystem. So let's take these elements and build out that solution fully. So now that we have that formula expression as part of the custom metadata type, you can SOCL for it, and that's available to you at runtime. Then we create the account. In this case, it's just one, because we are demonstrating the use case, but you would source all the accounts and your data that you need to filter. We're creating an instance of the account wrapper class that you just saw, that we defined. You're passing in, by passing in the account that we just created, so all our data is here. And instantly, you're able to calculate the sales pipeline value for this customer. Now you're ready to call the new Formula Builder API. We specify the return type of the result. In this case, it's just a Boolean. We specify the type of the object that we want to evaluate. In this case, it's an Apex object. That's the account wrapper class we just created. You can also just say, specify an S object here, like an account.class or a case.class. Then you also specify the formula expression that you're interested to evaluate with. And then when you call build, you create a formula instance. In the back end, it's firing all your formula syntax checking, your field validations. And once you have the formula instance, when you call the evaluate API, you're able to filter out all your accounts that match the expression that you have. And this is all happening at runtime and in memory. And this is really powerful because the expression itself, that you can change dynamically at runtime. You also see how we integrated with an external method, sales pipeline from the platform. And then, again, all of that evaluation is happening in memory, so it's really fast and performant. So Daniel, here you go. That's an account that you can send a gift out to.
Thank you. We'll have some happy customers and happy account team.
Daniel is going to, sorry.
That's right. All right.
Going back to observability.
Thank you, Bindu. So yeah, now we'll run through observability in Apex and what's changing there. So some of you may be familiar, if you have an unhandled exception in Apex, you can configure an email address that will get details of that unhandled exception. There's a few limitations there. One is that we're limited in the number of emails we can actually send out, and that's actually limited to about 10 per application server. So if you're throwing a large volume of errors, we may actually start truncating and not sending those, so you may not be fully aware of the volume of errors that are happening. The other challenge there is that particular limit is not actually org specific. It's across the entire pod. So if you have a noisy neighbor who's having a bad day and throwing a lot of exceptions, you may not even actually see your exceptions at all. And then once you do get those exception emails, if you're getting it in any sort of volume, having that detail in an email is not actually the easiest thing to work with in any sort of volume. You have to start parsing the emails out. It becomes quite arduous. So in Spring 25, you now have a free tier of event monitoring for the Apex unhandled exception event type, and this has been expanded to remote actions as well. This is great because you'll get one CSV file with the complete set of all unhandled exceptions from your code for the last 24 hours. Now you can extract that either through the setup UI, there's an event log browser, or it also has a number of APIs itself, so you can directly pull that down. And so you can automate the retrieval of those exceptions and you can start processing them in external systems. It's a really important mechanism to be able to be aware of what exceptions are happening in your org and to what volume. Right, so another important thing, agents of course. So in Apex today we have invocable methods, invocable actions that you can call from your agent if you want to use your existing functionality. But as a beta in Spring 25, this is getting expanded to your Apex REST methods. Another clear entry point into your Apex code where you have useful functionality that you want to be able to expose to your agents. To do this, you would take your existing Apex REST methods, and there's a new functionality in VS Code that can generate an open API spec that describes the shape and the parameters and the usage of that method. The open API spec then gets uploaded into your org along with other metadata as you would with a class or a trigger. And now, once it's in your org, it becomes part of what's called the API catalog. And the API catalog is exposed to agents as something that can be connected to actions. So this is a really useful mechanism for taking your existing code that you've already invested a lot into and exposing it for consumption from agents. And it's also really powerful. The Open API specification can have a lot of information that the class might not be able to have about the types of parameters, the descriptions of those parameters, all the information that the agent needs to know to be able to successfully call and handle the responses from your REST method. So that's certainly something to try out in your Spring 25 orgs. Now, another important part of that is, yes, agents need to know what your methods and classes are doing. And part of that is usually the first part, even the open specification to spec step is, what do these methods do? A large part of that is extracting data from the code comments put into your code base. Now, historically, Apex has obviously had code comments, but we've never had a formal structure that says you should format them like this so other parts of the system can understand them. So going forward, we're going to formalize on a specification. It's not going to be anything too extraordinary, or it's going to be unpredictable. It'll be very similar to like a Java doc style format where you can have params, descriptions of the return types. And so the key goal here is to make it consistent for all the consumers, the tools that both producing and consuming this information just have one format to work with.
What happens if you don't conform to the format?
Okay, yeah,
100%.
so that's an important point. Obviously, this is something new we're introducing. A lot of you might not be following this format. We won't throw compilation errors. This is more just something we're adopting as an opinionated form for consistency. You can still continue commenting however you like. Yeah. Right. And with that, let's talk about managed packages. So both as producers of packages and subscribers to packages, which is pretty much everybody, under first generation managed packages, if you have a dependency from your class into that managed package, that's represented in the metadata for the Apex class. So say like we have an eShop managed package here, and your class calls one of the global methods exposed in version 1.0 of that. In your class metadata that gets deployed to the org, there will be a dependency saying, I depend on version 1.0 of that managed package. Okay, so now we're coming to the world where we're all going to start migrating to second generation managed packages. Well, there's a challenge there. Second generation managed packages don't just allow one package per namespace. You can actually have multiple packages per namespace. That's of course a problem for this metadata because it's no longer a one-to-one mapping. So to address that, when second generation packaging rolls out as a migration for your first generation packages, we're going to adapt a new format which allows you to specify the package ID instead of the namespace. And that will again restore that unique one-to-one mapping. If you look at it through the setup UI, you'll still see the namespace. It's still doing the same thing, but it just makes that mapping a lot more, well, exact, which is what you need for when you're tracking those dependencies. Now, the other part with packaging, ISVs might be particularly familiar with this, are globals. So say on a Friday, sales team comes to me and says, we've got a hot customer, we've got to make this sale, we need this functionality to get the orders for the customer, can you just put it in the package? So you rush that out, you get it out on Friday, everybody's happy, and we've shipped it and we're done.
Uh-oh, but I see some syntax errors in our code here.
Yeah, okay, so maybe in my haste, I made a few mistakes. I made a few spelling mistakes. I didn't quite consider the shape of the API. But that's okay. I'm going to deprecate that method. I found there's a new internal package that's much better for handling that. Let's use that instead. We're done. And whoops, actually, I realized I've accidentally left the dependency on the old package in there. And now I've got a problem. ISVs in the audience may have started cringing a little bit at that because that dependency historically would have been locked in. There would have been no way to remove it. Well, I'm happy to report that we've fixed that. Even though something's deprecated, you can still actually change the body of the method. You can't change the signature, but you can remove that dependency so you're no longer locked into that. So that's one nice feature. But we've still got problems like my order management class is still misspelled. That's not a good look. So let's fix that. Let's deprecate the entire class. Well, now I've got another problem. This global, even though it's throwing exceptions, is basically going to live in my package forever. I can't remove it. That's another thing we're looking at introducing a change for. It's coming soon. We're going to refine that so that on major package upgrades, so that the major version number is changing, you'll be able to remove deprecated classes and methods. And that's a great tool for cleaning up the long historic code that you would have had accumulating in large managed packages that have been around for a long time. And with that, we'll do a quick run through of the roadmap. So we've already talked about a number of these points. A couple of things we didn't have time to go into in depth. The long-running request limit for the number of concurrent long-running requests is now based on license of the orgs. So larger orgs will naturally have a larger long-running request limit, up to about 50, depending on the number of licenses they have. You can also now pause and resume scheduled jobs directly from Apex, giving you the control there if you need to stop them for some long-running request or something. In terms of short-term things, I think we talked about most of these. We're doing a lot of behind-the-scenes things to enhance compilation in Apex. If we do our job well, you probably won't even notice that, or things will just be naturally faster. Coming longer term, Again, we have some interesting features around the concept of named SOQL queries, almost like a stored procedure from Apex that you can use to retrieve information. Again, we talked about the global deprecation. Right now, generics are actually back in the backlog for us while we're focusing on other key features for Apex around agents and Data Cloud. Now with that, these are the resources. You can scan that QR code. I'll post the slides there, all the other information you might need. I'll give that for a second. And yeah, we'd love your feedback on some of these features that we're working on towards GA. Hopefully you all got that. All right, and with that, I'd like to say thank you, everyone.
Thank you for coming.